Alright, so let's multiply fractions. So the nice thing about fractions is you never have to find a common denominator. So we talked when you added how you boom, boom, pow. Well, with fractions, we're just gonna pow, pow. So you just will multiply right across. 3 times 2 is 6. 4 times 7 is 28. However, we know that 6 and 28 are both even, so we'll divide each one of them by 2, and that would give us an answer of 3/14. So multiplying is a lot easier. No common denominators needed. You just pow, pow. For the next one, so we have a negative and we have a positive. So we know when you multiply or divide, if the signs are different, the answer is negative. So we're going to pow, pow again. So remember, this minus sign right here is going to go up to the 5. So that would be negative 5 times 1, which would be negative 5. And then you have 8 times 3, which is 24. And that does not reduce, so negative 5 over 24 is your answer. For this one, we have two negatives, so we know if we multiply or divide where the signs are the same, the answer is positive, so our answer is going to stay positive. Now, we could multiply across, and you could get 12 times 3 equaling 36, and then 22 times 4, 88. And since they're both negatives, again, like I said, both fractions are originally negative, our answer is positive. Now, 36 over 88, we would have to reduce. So we would cut each in half because they're both divisible by 2 because they're both even. That'd be 18 over 44. And cut them in half again, we get 9 over 22. That would be your final answer. There's nothing wrong with doing the problem like this. But there's something else called cross-canceling that you can do, which will avoid all of this reducing at the end. So to do that, we look at our original problem. And we will look across from one another. So I'm going to look at this numerator on the left and the denominator on the right. And I want to say which number goes into both of these. Well, the number 4 goes into both. So I will say 12 divided by 4 is 3. And then I'll say 4 divided by 4 is 1. So I turn the 12 now into a 3, and the 4 turns into a 1. And if we multiply it across, negative 3 times negative 3 is positive 9. 22 times 1 is just 22. It's a completely different way of solving the problem. Either way is correct. I find cross-canceling to be very, very helpful because then you don't have to worry about reducing. Okay, with this one, so we have mixed numbers. We're going to want to change our mixed numbers first into improper fractions. So to do this, 5 times 2 is 10, plus 1 is 11. Since the whole fraction is negative, I'm going to put our negative sign in the numerator. With the next one, 2 times 8 is 16, plus 5 is 21, and we keep the negative sign. So here, we cannot cross-cancel. I looked to see if we could. We can't. That's okay. So we will just do now negative 11 times negative 21, which is going to be positive. So remember the trick for multiplying negatives. We do 2 and 1, because we separate 21. 2 plus 1 is 3, and I put that in the middle. So that'd be 231 over 16. Now, this does not reduce, so you can leave that as your answer as an improper fraction. That's fine. Last one. So I'm going to show you again that cross-canceling. So we know a negative times a positive is going to be negative. Let's cross-cancel. 7s, let's look at the 7s. What number goes into both 7 and 7? Well, 7. So 7 divided by 7 is 1. 7 divided by 7 is 1. Next, we're going to look at 30 and 6. 6 goes into both. 6 divided by 6 is 1. 30 divided by 6 is 5. Now we multiply across. Negative 1 times 1 is just negative 1. Then in the bottom, 5 times 1 is 5. Negative 1/5. Had you multiplied across, you would have ended up with negative 42 over 210, which you may not realize, but you can reduce that in order to get this. So again, cross-canceling makes things a lot easier when it's time to reduce. Well, see you later. Bye.